The broadcast is now starting. All attendees are in listen-only mode.
All right, everyone. I'd like to welcome you back to another KevCAM night class tonight. Tonight, helping with questions or concerns is Shay. Shay, are you with us?
I am with you. Hello, everyone.
All right, and then as well as Greg Payton to make sure I'm hitting all my points and making sure we're I'm not missing anything for you guys. So, Greg, are you with us?
Good evening, everybody.
And we were talking after the last night class how Greg is good for throwing those zingers at the last second. So we'll see what he's got tonight for us.
No bus is coming your way this time.
Okay, so I do see a lot of new names in here, which is great to see. I'm just going to go over some quick housekeeping stuff. We are using GoToWebinar. That does put everybody in mute just to eliminate any background noise. If you guys do have a question, definitely feel free to type that into the questions panel. Shay will read that off to us, and we'll get that answered for you right away. These night classes are solely dedicated just for you guys, so definitely feel free to ask as many questions possible. As you can see, we'd like to keep this very light and humorous, especially after hours. So with that being said, every night class is recorded, and if you guys would like to see a previous night class, you guys can head over to YouTube and type in SolidCAM University or KevCAM, and all of our night classes, as well as Mark has done a great job on some shorter videos in here, live cut videos. There's pretty much everything on how to do anything inside our software available for you guys here. So another great source to come in there, and if you guys would like to see something different in there, send that over to me via email, and I will get those implemented in there for you guys.
Now, speaking of live, are we still doing this on Facebook Live?
Oh, dang. Yes.
Oh, never mind. There was one bus.
Yeah. Okay. Sorry, guys. Just bear with me for a second here. Keep forgetting about this Facebook Live stuff, and so this is a great point. So if you guys are looking for a kind of a users group, there is the SolidCAM North America, which I always forget how to do it in here. I think we have to go like this, live video. Sorry, everyone. And
we get a free tutorial on how to start a Facebook Live. That's nice.
Yeah.
For all of those who thought we were just getting iMachining this time around, we got some DLC content.
So we also have the SolidCAM programmers group as well. So I'll get booked in there real quick.
Maybe while you're setting it up, can you give us a rundown of what's going on with each of these groups for people that do have questions about things or want to use the group as a sounding board for anything SolidCAM related? Maybe you can speak to more about that.
You think I can do two things at once? You're crazy. Okay, get that. Okay, so I think we're going live on Facebook as well. Okay, so yeah, the Facebook group is definitely a place for you guys to maybe after hours, or if you guys are looking for questions on tooling, tool holders, fixtures. Like Greg was saying, it's a great place to come as a community, get some input or ideas on maybe how to machine a specific part or something like that. We will hop in there every once in a while and help you guys out with questions as well. I know Mark is constantly on there to help anybody out that is having questions on there. But like I said, it's just kind of a community center where a bunch of us machinists can get together and bounce questions off each other and whatnot. So like I was saying, that is SolidCAM North America, which is US only, and then the SolidCAM Programmers Group worldwide. So definitely come there and check it out. Okay, so no more buses coming our way, is there, Greg?
Not at this time, but the night is still young.
Yeah. Okay, so we'll get the ball rolling here. So what we're going to be covering today is the iMachining feature recognition that is available inside the software. I'm gonna go ahead and open up an iMachining operation and just kind of backtrack a little bit what we've talked about the last 2 weeks. So our first one is all based off of feature recognition by faces. So all you have to do is, if you're looking to machine a specific area, is just click on that face. And it can be on the top face, and it can be multiple faces. But we don't want, in certain scenarios, if there's overlapping geometry in there, sometimes it will not get all the faces just because like I said, we have overlapping geometry in there. So very simple, easy to use. Next one over is our feature recognition by chain. So this is going to be kind of for, let's say, open pockets that are not blind, slots. We did a single line geometry last week as well. So that's a great feature to have. Now, the easiest one out of all of them is the outside recognition. So the reason why it's easy is I don't have to pick anything. So what it's going to do is it's going to look at the target, our SolidWorks model, as well as our stock, and it's going to machine everything up in between there. So I'm just going to show you real quick here. Is in this particular operation, we're doing a profile to go around the outside, as well as a finish pass to finish that off down there. So now what we can do in here is go ahead and open up our iMachining here. And we'll do the outside feature recognition. Now, it is going to be looking at our stock. So right here, it's automatically set to look at the stock. If we wanted to pick a different stock in there, we could browse to that one as well as if we're running a fixture, we'll have the fixture recognition available. You'll see that the fixture clearance is grayed out currently to 2 millimeters on this part. We'll get over to an inch part next, but 2 millimeters, and I can't change that number. The only reason why I cannot change that number is because we don't have a fixture assigned to this part. So I'll bring you into another part where we do have a fixture in there. As well as we do have the option for floor fillets in here, but if we're cutting the outside of our part, we really don't care about that. So it looks a little bit, for those of you guys that are moving over to 2020, it is gonna look just a little bit different from what you guys are used to seeing in here. And then our last option is basically iMachining old school. So no feature recognition, no advanced stuff. You'd have to mark your chains open and close and so on and so forth. So get this part over here and go ahead and grab a tool here. And we had a 20 millimeter, that should work. Actually, I should measure my radius here. So, yep, that should be perfect. Okay, so now that I've picked my geometry, or I'm sorry, my tool, you will see that it automatically highlighted in a light blue section of everything that it's going to be cutting. So this is a real nice feature. So normally, if you guys were to do this in iMachining, we'd have to chain the part, and then we'd also have to chain the stock and mark that stock as open, where now it's all set up for you. So we don't have to worry about anything there. And if we'd like, we can do a finish on our wall. And at that point, we're basically done. If we want to dive a little bit deeper in here, we can adjust our wizard, maybe go faster or slower, as well as, since we are not running this on a fixture, we probably want to go just a little bit farther past on there. So I can come in here and put just a delta of 5 millimeters in there. And from right there, like I said, we can just save.
All right. Did we lose Kevin?
I believe we did.
Okay. Well, he must be having some technical difficulties, but we'll try to get him back online. Now, let's see. It looks like we do have a question from Duncan.
Duncan did write in.
Yep, it did freeze for everybody else, so not just you, Duncan. I think this is, well, probably Kevin's up in Minnesota, so it froze more than anybody. Let's see.
And he and I did do a demo today, guys. And yeah, he had snow all over the place, so I'm assuming that's it. What do you say, Gary?
Well, Gary doesn't say it a lot. I'm Greg, but pleased to meet you.
Oh, sorry, Greg. I meant Greg.
Yeah. So we'll wait for Kevin to get back on the line, but just kind of reiterate what's going on with the toolpath that Kevin's trying to do. Essentially what we're looking at doing is taking the same iMachining algorithm and the toolpath that's applied, the stuff that we've shown over the past couple weeks with iMachining, and kind of condensing that down into a singular operation that is easy to remove the outside of the stock. So like Kevin was saying, we're not really doing anything with any geometry selections, because when we define the part, we already know what the target is, we already know what the stock is, and we can take the extents of the stock and cut it down to the target model. Now, hopefully when we get Kevin back, we could get him to show maybe some of the multi-tool functionality, because as we can see in the blue highlighted areas there, that the radiuses didn't exactly match up. So we're using a larger tool for roughing, but what we can do is we can actually bring in the same operation, a tool that's closer in diameter or smaller in diameter than the radius is on the part itself. So hopefully he gets back here shortly and he can show that off. And we'll ask him to do that. But up until this point, does anybody have any questions about what they've seen so far, or maybe anything that relates to iMachining as we've seen over the last couple classes? Are you seeing anything come through?
Yeah. Let's see. Well, did it freeze?
Okay, we got Kevin coming back.
Okay, sorry about that, guys. In my shade, it happened again.
I noticed. I tried to warn the fellas.
All right.
During my song and dance, Kevin, I signed you up for showing us the multi-tool functionality as well.
Absolutely. Now on this other computer, I just gotta figure out how to share my screen. Yeah. Make presenter. All right. Is everybody able to see my screen now?
Yes.
Okay.
Yeah, we got a different part up there, but yeah, I think we're back.
Completely different. Yep, completely different part here, but I think I do have, let me turn off my path here. Okay, so on this one, we do have a fixture in there, and I'm just gonna get back to where we were here. Okay, so I can't remember where I quite cut off here, but we are doing the outside perimeter. Set my technology to be level 8. And with this particular one, we do have a fixture in here. Oops. And boy, I'm just having all kinds of, there we go. Okay, so we do have a fixture. So with that being said, if we go over to my fixture area, and if I go ahead and turn on my fixture protection, we can see that it's not grayed out anymore. So if I want, I can make that number as small or as big. And what that means is that tool will come in contact or will come within. Right now it is set to 100 thou if we want to do 1 thou of that fixture. So if I go ahead and save and calculate here.
And what's nice about it is you see the shaded volume removal indicators there, that light blue transparent shading. So as you manipulate those values, you can see the projected volume removal being updated.
Absolutely. And so without even running this through in simulation, I can see that I'm still not going to be able to get all the material that I would like in there. So what I can do is either A, I don't have to worry about the fixture, and we can just turn it off. And now, like exactly what Greg was saying here, is now it's going to show that we're removing all the material that is there. So we can save and calculate that, and we can see that our toolpath will update to that as well. Now, for what Greg was talking about with the multi-tool, since I'm on a completely different computer here, let me just...
Yeah, different computer, this part's really not going to lend itself to it unless you can find that same part on this one. Because what we needed was some internal fillets.
Oh, you're going to make me dig on that one. Okay, let me go to downloads. It's in the training files. Actually, let's just do this.
Yeah, the training files that you're using are the same files that everybody can grab off the SolidCAM site, right?
Absolutely, yep. And what I'm going to do is just copy that.
So if there's anybody out there that wants to kind of take what they learned from this class and apply it on their own systems, those files are available for download from solidcam.com. And you're using what, the 2.5D exercise?
That's right, yep. Now I can find where my zip folder went. There it is. Extract files. Sorry, everyone. Like I said, been having little computer issues with my other computer, so. All right.
I think the other computer's just so tired.
It probably is.
Long days on the support line.
Yeah. All right. So it wasn't that one. It was that guy right there.
We're probably bouncing around on that tractor.
Yeah. Now that we got 2 feet of snow on the ground, tractor ain't going to do me much good anymore. All right. So let me get over to a different post processor here. Okay. I'm just going to calculate that first operation. Now, get back to our 2.5D, get back to our iMachining here. And like I said, we're just going to pick the easy option here. So to machine the outside of our part, go ahead and select our tool. And let's start with something big. So we're going to use, well, what do we got? 20 mil, 3.5, 8, 12, 4. So we'll start with this 20 mil here. Now, in the particular scenario where that tool is going to be too large, what we can do in here is tell it that we'd like to finish the wall. And now we can come back and grab a smaller tool. So we got our 40 mil, and and we'll go to this 12 millimeter. So then whatever the 20 millimeter can't get to, the 12 millimeter can get to now. Now, let's say we want to do another step down if we want to do a 6 millimeter. So at that point, I could keep adding tools in here and it would just cut only the remaining stock that is left over. It will not cut air, it will just cut the remaining material there. And we're telling it to finish on both of those. We'll save and calculate here and not completely shut down my computer. Okay, so now if we go in here and simulate this, we can kind of see what we've done. So we got just our standard block coming in there with that big 20 mil, just machining the outside. And then it's going to do one nice finish pass around. And now we're coming back with that I can't remember now.
It's a 12 millimeter.
There you go.
But
12 millimeter end mill.
Might need to go a little bit smaller still.
Well, let's find out. So we got our stock target comparison, and yep, Greg is right. So we'll even add another tool in there now.
Yeah, I believe that's a 5 millimeter radius.
Okay.
So maybe grab that 8 millimeter end mill that you had in your library.
All right, so now we have 20 stepping down to a 12, stepping down to an 8. We're telling it to finish. We can go ahead and simulate this. And what it's going to do is you'll see that it's calculating the tool path for each one of the operations. So even though that we're doing all three of these tools all inside one operation, it is creating 3 independent operations over here as well. But the nice thing when we're using the multi-tool function is maybe on one of the tools I want to run a slower feed rate, or I want the wizard to be slowed down. I can do that right from inside there. And I'll show it once I get done simulating this here. We'll go back to Solid Verify here. So there's that 20 millimeter, do a nice finish pass, coming back with that 12 mil.
Now what's nice about this is that each of the subsequent tools that you're running is going to be ran through that iMachining algorithm, which means that you're getting that consistent cutting angle for each and every tool. So even if the rest material is too much for that particular tool, iMachining is going to add in the passes necessary to keep that cutting angle consistent, keep that load off your tools and spindle, keep the forces out of your part, regardless of what the tool size is. And maybe we can show that by getting rid of that 12 millimeter and just seeing what the 8 millimeter tool does when we go from a very large tool to a smaller diameter tool.
And if we can just pause that, and we'll just come in here, delete that tool. So now we're going from a 20 to an 8. Save and calculate here.
Yeah, let's kind of watch it after this tool is finished and see exactly what that 8 millimeter is doing.
Absolutely. if I just do the next operation here. Okay, so now this is exactly what right before our 8mm end mill is going to come in there. If we do our stock target comparison, we can see, you know, we're finished up all on the sides right here, as well as the sides over here. But where we still have that remaining material left over is right here in the radius. So come in here, gonna get this repositioned for you guys. That went a little too fast. You can see that it's just focusing on just the remaining material there. It's not cutting any air. It's just coming over here and just taking those slices out of there just to get that material out of there. As well as, since we did the iMachining, like Greg was saying, we don't have to worry about the feed rates, step down, step overs, how much to take per pass. That is all built into the iMachining algorithm for you guys. So you guys don't have to worry about that. Now, one thing I've kind of overlooked a little bit is how are we able to tell how fast we can go with that tool? I'm sorry, we still had that 20mm in there. Now we're cutting with that 8mm. Trying to catch up to it here. So we got that all roughed and finished now. And now when we come into our stock target comparison, we can see down here we are up to size. Now the reason is blue up here is because this material still remains there left over. So it's not going to be, we'd have to do another iMachining operation to get that material out of there. But as you can see inside the radius as well as the outside, we are up to size. So, and one thing to kind of remember too, you know, you see orange here, that's a little bit showing up almost as a gouge, but it's really not. It's just meaning that anything from 0 to 9, was it 0.009 millimeters, 9 microns, is good. Anything that is showing up in red or the darker green or blue is meaning that we still have material left there. So. Was that what I was supposed to show there, Greg?
Yeah, I believe so. I mean, it's what's nice about it is that it's not like it's sending in that second tool and just cutting one finished pass. Because if you're going from something that's a large diameter tool to something that's considerably smaller, you are going to get that over engagement. So iMachining automatically recognizes that the material is going to, or the rest material is going to exceed the cutting angle that the tool is capable of, and it automatically inserts those extra passes to make sure that you don't damage that tool.
Yep. Now, what I was getting at before is if I wanted to switch, so let's say my 20mm, I want to run as fast as I can go. So I can run level 8 on my 20mm or my tool number 2, but maybe on my number 4 tool, I want to run at a level 5. So that's how you guys can switch back and forth between these two, is just by coming up here. There's no need to save and calculate and come down to number 4. Once you save and calculate, it will save and calculate both tool number 2 and number 4, as well as there is no reason to exit out of this operation and go into this operation down here. So everything is going to be automatically adapted for that. And we're kind of talking about with the feeds and speeds. This is all based off of we are using, or we are cutting 1018 cold rolled steel that we told it, cutting on our Haas machine. And now we only need 3 variables from that Haas machine, and that is the max feed rate, max horsepower, and max RPM of that machine. And with those 3 variables, as well as our material that we are cutting here, as well as in our tool, if I come in here and do a select, you guys will see in there, there is a iData tab. And inside this iData tab, it's just letting us know what material that we're cutting, but it also wants to know what kind of material our end mill is made out of. So if we're running a carbide end mill, or if we are running a coated carbide end mill, that would be a premium. There's cobalt, high-speed steel in there, as well as the helix angle in there. So now when you get into the softer materials, helix angle isn't as important as if we are running, you know, Inconel or titanium and stuff like that. So if you guys don't know what that is, you can usually just go right to your tooling manufacturer and they'll tell you what the tool helix is. And if you guys have a variable helix in there, just go for the middle number. So let me just add a tool in here real quick.
There is a question in here. You want me to let you finish and then read it off?
Yeah, go ahead and read it off for us.
Okay. Just, I'm sorry to butt in, but the question is, even though all of that was done in one operation, can you reorder them and still edit in that one window?
You know what? I've never tried it, but let's do it. Let me get this iData here. So we're going off of number of flutes, and well, as well as coming in here. And now I have to create a new tool, but let me just do that real quick. Hop out of here. So if we go to our iData tab, so I have the option to select from carbide, cobalt, high-speed steel, and premium carbide. Like I said, the premium carbide is going to be your coated end mills. Now, in here, we have the standard helix angles in there, but if you guys are running into like a 42-degree helix, just type that number in there. Even though it's not as a drop-down, you guys can type that number in there, and it will bring the data in there for you. Okay, so let's make a mess out of this. And I'm gonna come over to my iMachining and drag it down. And let's just calculate all this stuff here. Okay, so the question is, if we reorder them, can we skip back and forth between them? And my answer is yes, but I just want to make it 100% sure before I tell you. So, oh, I clicked too many times here. Okay, so now we have them completely separated out here, and let's just do our technology wizard. We'll run tool number 2 at level 6, as well as tool number 4 at maybe a level 2. Save and calculate. And you'll see that it is updating. It updated the first one here, and it's going through and updating these files right here because it is all based off of updated stock. So we have to verify the stock left over from these, and then it will be calculating our last.
Take a look at the box on the top of the screen. It disappeared now, but it basically had to run through every single operation to get to that updated stock for the lower one.
Yep. So to answer your question, I'm not sure who was asking that, but that is, you can reorder these however you would like. And now that, we've been talking the last couple of weeks with feature recognition, chamfer recognition, pocket recognition, iMachining with all the recognition. One thing that will definitely help you guys out is, let's say I make a change to something up here, then you'll notice that some of my operations down here get out of sync, which they put the little star there. So instead of hitting your save and calculate button, just move over just one right here and do save and calculated with all related. So what it will do is, when we do save and calculated with related, is it will automatically calculate the ones that do get out of sync as well. And how to tell how they're out of sync is you can kind of, or how they would be affected, is I can see this iMachining operation is tied to our face mill operation as well as the iMachining operation down here, where, on a simple profile operation, it's not linking to anything at all. But if you guys are running a lot of iMachining, or like I said, the pocket recognition or any of the feature recognition programs in there, definitely do the save and calculated with related operations, and that will save from, calculating this, and then all of a sudden I got 3 broken ones down here that just need to be calculated. So just save you an extra step doing it that way. So.
Now, Kevin, what would you say would be best practices for, instead of doing this iMachining and breaking it up with a bunch of different profile operations, just iMachining with multi-tool where the operations are stacked? I've known that I've heard that you want to go with the largest tool and kind of cascade down to your smallest tool. Would you agree with that?
Well, yeah. So, that brings up a good point. When we had in this operation right here, we had the 20 millimeter, we had a 12 millimeter, and the 8 millimeter. Well, there's no reason why, if we're going from a 20 to a 12 to an 8, to run that 12 millimeter, because the 8 millimeter is going to do just fine cleaning up where that 20 millimeter left off at. If you're cutting harder material, definitely step it down. I guess it all depends on material that you guys are cutting. But I would, like on a particular part like this, we're cutting 1018 cold rolled, going from a 8 millimeter to, or I'm sorry, a 20 millimeter to an 8 millimeter. I'm not going to worry about that at all, just because, like Greg was saying before, iMachining is not just going to take and do one finish cut with that 8 millimeter. It knows what material is still left over, and it's going to slowly approach that material and get that material out of there. So,
well, there are going to be instances where you're going to want a higher tool rigidity that comes with larger diameters. So,
yeah.
For this in particular, all we're really focused on is a small radius in those 4 corners. But if we had some heavy roughing everywhere else, you probably want to go with a beefier tool and kind of step it down. And also, larger tools means that the cutting angle is going to be larger, which ultimately results in a step over being larger. So it could end up being faster in the long run, provided you had a machine that had a pretty decent tool change time.
Yeah.
If you're like on our old Fidal where the tool change is like 20 seconds chip to chip, then maybe you leave that 8 millimeter in there. But on some of these new machines, they're pretty damn fast that it's almost scary how fast they can swap out tools. And so maybe going with a larger diameter tool will be better for a faster cut in the long run.
Yeah. Absolutely. And one thing I don't think I mentioned this in the last iMachining night classes that we did, but the feeds and speeds will be based off of how much of that tool is sticking outside of the holder. So let's say we're just having a small little cut here, but I have 6 inches hanging out of the tool holder. Well, iMachining is going to take that into factor, that 6 inches versus 2 inches sticking out of the holder. We're going to get some flex going on there, and iMachining with the built-in algorithm will automatically calculate for that stick out too. So it really is hitting the easy button, taking out the guesswork for you guys and really helping you guys out with that. So.
Now, we've kind of seen this from an in-depth perspective, but why don't you go ahead and clear out these operations and just kind of do it as a flyby, just to show everybody just how easy these
Sure.
operations are.
So delete everything now.
Well, I mean, just the iMachining operations is what I was thinking, but yeah, if you want to take everything, you can.
Okay, so just so we're machine the outside, machine the inside is what you're looking at?
Well, just showing this particular operation, yeah, machining the outside. Because I think
Okay.
what gets lost in some of these classes as we're going through the minutia of all these operations is everything that we show is kind of like an in-depth tutorial on what's going on and not what's going to be like a real world scenario. So like if you had your own shop and you were just going to program this part for yourself, what would be involved in going into the programming of this operation?
Okay, so first thing, one thing is when we're setting up our coordinate system, first thing that we're going to want to do is set up our iMachining data. That's right here, as well as what material that we're cutting. So we're currently going to be cutting this on a Haas SS, cutting 1018 material. Now in here, you guys do have a huge selection of materials in there. For those of you guys that don't know, you know, I have made these custom materials in here, which is very easy to do. And I suggest you guys doing it if you guys are cutting any materials in here. These are kind of a general basic materials that what you guys can do is if I open up my internet here and go to the website, mattweb. Nope. mattweb. That could have been bad there for a second. Okay, so in here, I can just type in a material. So we'll just say 6061. Do a search on that. And what I'm looking for in here is the material that closest resembles of what I'm cutting. So I'm cutting 6061. Oh, I'm sorry, I did 1018, didn't I? 1018.
Now, what you're showing off now only has to be done once per machine and per material, correct?
Correct. So once it's in there, it is in there for the life of
You're
SolidCAM.
just establishing the database at this point?
Yep, absolutely. And the one number that I am looking for is the ultimate tensile PSI. Now, with this part, we are running in metric, so it's going to be 440 MPa. I'm not sure what that is, but that's the number that we're looking for. So if I wanted to create that material, I can come in here and just say new material. This computer's going slow on me.
Don't push it too hard. We saw what you did the last one.
Yeah.
Computers around the world are scared of you now.
So now new material, we can just, well, I already got 1018, but now right here is where I can put in that 440. So I could put in that 440, put that number in there. Then that, like Greg was saying, I have that for the life. So that's in your entire database. So now when we get into the programming side of things, I'm going to come in here, do my 2D iMachining. And I want to machine the outside of my part. So I just told it to machine the outside. We'll go ahead and grab our 20 mil. And I have my iData all set up. We're cutting with a carbide. And if we want to, usually I'm running premium carbide, so, or a coated carbide end mill, 45-degree helix. I can accept that. Now, how this would work normally is either A, I would come in here and get a measurement, or B, I would just play this through and see if I have any material left over. So now, since we know we still have material in the corners, I'm going to go ahead and grab my next tool, which is my 8mm. And you can see this one's sticking outside the holder a little bit farther here, so it's automatically going to compensate for that. Now, I want to go just a little bit farther past. So I do have some material, because this is what my stock is currently, is this wireframe. So I want to go just a little bit farther past there, so when I go to flip this part over to do a face mill operation, I won't be running into that sharp burr right there. So I'll just tell it to go -5 mil past. Now, on my 20 millimeter tool, that is a very stout tool. I can crank that baby up, so especially if we're running this on a Kurt Weiss and good tool holding, we can run this up level 8. And if we want to go a little bit faster, we can turn on turbo. And what turbo is going to do is it's going to increase the step overs for you guys. It's not going to change the feed rate. It is just going to increase your step overs. Now, my wimpy tool number 4, my 8 millimeter that has a long hangout length, I'm going to dial that one back down a little bit. We're going to run that one at level 4. So now that I have all that set up, I would also like to run compensation for both tools. So I'm running comp right there. I have a RA finish that I would like to achieve is there. And that's pretty much it. I'm basically leaving 0.3 millimeters on the wall for that finish pass. So what's going to happen here is it's going to machine everything up to that 0.3 millimeters in there, and then it's going to do one nice finish pass to clean up that 0.3 millimeters. Now, I think Greg talked about this just a little bit, but what this will do here is, even though that I left 0.3 millimeters on there, if that's too much material for that tool to come in, it's still going to come and do the D-slot tricoidal movement in the corner to get that material out of there. So it's not taking that full 0.3 millimeter and over engaging the end mill at that point. So, okay, so we will go ahead and simulate that. Oop, I should have done save and calculate. Sorry, guys. Save and calculate here. There we go. Now, if we run our solid verify here, kind of like what we did before, and hopefully this is what you were getting at, Greg. If not, please tell me.
Yeah, I think what I was getting at was the programming of the operation without the explanation, but the secondary explanation was good as well.
So now we have a completely finished off part there,
yeah,
or at least on the outside.
Rare circumstances where the sequel was better than the original.
All right, any questions from anybody here? I can't see the questions, so I would assume they would let us know, but just give you guys a second here to throw any questions in there. For those of you guys that don't have my email address, I am going to put my email address in there for everyone. All right, so actually, I do entire audience. There we go. So everyone should have my email address. If you guys do run across questions, definitely shoot me an email or give us a call on the support line. But another thing too is, if you guys want to see something different in there, definitely send those ideas over to me via email, and I'll get those added in for the class lineup as well. One thing I do want to ask everyone here is, for the last 2 episodes that we've started this an hour earlier, does it time matter for you guys on that? If I can get some people thrown in there, they like the the 7 o'clock better than 8 o'clock, or they like the 8 o'clock better than the 7 o'clock. Someone can just let me know. Looks like it doesn't matter. But okay, well, I'll stop rambling on here. That's everything that I have to show for tonight. Greg, can you think of anything else?
Just real quick, for those that want to try this at home, can you open up the SolidCAM website and just show them where they can navigate to find these files?
Yeah, these are great files to have. So on our website, you guys go to subscription and hit the drop down and go down to documentation. Now, you guys can pick the different years that you're looking for if you're running InventorCAM or SolidCAM. So we'll click on SolidCAM 2020. And then we have general documentation right here, which there's some good stuff in there, but to get you right into the good stuff, hop right over to the milling section. And right here is the book and here are the parts that go along with the book. Now, when Greg goes on site and does training, when I go on site, do training, any of our tech guys come on site, do training, this is what we're gonna be teaching you guys here. So like, some great stuff here. Now, if you guys do see down here that these are grayed out for using HSM, Turbo, HSR, HSM, all these other functionalities there, that just means you need a login. And if you guys don't have a login, you guys can create a login with your account there. So, but these are completely free to you guys. If you guys need help navigating to that as well, let me know how we can help you out there.
And if you don't have an account, you can contact Shay, and he'll be more than happy to set you up with one.
Absolutely. Unless he's sleeping.
I'm right here listening.
So, all right, guys, we did go a little bit long today, but that's good. I really want to apologize for the computer issues. I'll get that fixed up by next week. And on that next week, we will be doing the non-feature recognition of iMachining because, as we all know, not everything can be programmed with the feature recognition. So we'll get into the non-feature recognition of iMachining and show you guys that next week. All right, everyone, have yourself a good rest of your evening, and we will talk to you guys next week. Bye-bye now.
Bye.